In the last video, we introduced the concept of numbers and units. Almost every number has two parts: the numerical value of the quantity and the unit, or what that quantity represents. The unit must be given for clarity because different units can be used to represent the same quantity. For example, the quantity of length can be expressed in the units of centimeters, meters, kilometers, and inches, just to give a few examples. So 12 centimeters does not equal 12 inches, even though both are units of length. So to be clear on what we mean, the number must have a numerical value as well as a unit. In physics, the standard of units used to measure physical quantities is the International System of Units, also referred to as the SI system or SI units. The SI system defines the fundamental or base quantities. There are 7 such base quantities. All other physical quantities are derived from these 7 base quantities. The first defined base quantity is the quantity of length. The unit for length is a meter, and its unit abbreviation is the lowercase letter m. The second base quantity is time. It has a unit of a second, and its unit abbreviation is the lowercase letter s. The third base quantity is mass. It has a unit of the kilogram, and its unit abbreviation are the lowercase letters kg. The fourth base quantity is electric current. It has a unit ampere, and its unit abbreviation is the uppercase letter A. It's uppercase because it is named after a French mathematician, André-Marie Ampère. The fifth base quantity is temperature. It has a unit of the Kelvin, and its unit abbreviation is the uppercase letter K, named after Lord William Thomson Kelvin. The sixth base quantity is the amount of substance. It has a unit of the mole, and its unit abbreviation is the lowercase letters mol. The last base quantity is luminous intensity. It has a unit of the candela, and its unit abbreviation are the lowercase letters cd. There are 7 base quantities as previously described. All other physical quantities are derived from these base quantities. They are called derived quantities, and the units are derived units. Take, for example, the quantity of speed. Speed is defined as the distance traveled over the time taken to travel that distance. Since the unit for distance, or length, is a meter, and the unit for time is a second, then the derived unit for speed is meters per second. Consider the volume of a box, which is defined as the product of the length of its 3 sides. What is the derived unit for volume in SI units? Before you move to the next video, be sure to complete the practice questions. This will help reinforce your understanding of the concepts explored here.